Good afternoon and welcome to the Tropical Topics Week put on by your local National Weather Service offices in Florida, the National Hurricane Center, and the Florida Division of Emergency Management. I am Jessica Few. I am one of the lead forecasters here at the National Weather Service in Tallahassee. And I am also joined by Dan Noah, who is the Warning Coordination Meteorologist at the National Weather Service in Ruskin, or the Tampa Bay area. So we are your moderators for today and through the remainder of the week. Just a couple of logistical items to go through before we get started. Due to the large number of participants on the call today, we do ask that you submit your questions via the questions box or the Q&A box in GoToWebinar. We will take those questions at the end. If we don't get to your question today, we will send you a follow-up email to answer that question. The presentation is being recorded, and we are going to stop the recording before the Q&A session. The recording and the PDFs of the presentations will be available on the same website that you registered on. The ones from Monday, Tuesday, and Wednesday are already up there, and then the ones for today and Friday will be up there by Monday. We have had a couple of questions about certificates, so just keep in mind the email for that should come about 1 hour after the training session. It comes from GoToWebinar, and there's going to be a link at the bottom that says My Certificate or View My Certificate. And make sure you click on that link at the bottom of the email and then give it about 1 to 2 minutes for that certificate to load. So today's topic is the rainfall threat. So I'm going to pass it over to Mark Wool, who is the Warning Coordination Meteorologist in Tallahassee, and he is going to kick us off for today. So Mark.
All right, thank you very much, Jessica, and good afternoon, everybody. So today we're going to talk about the flooding rain threat portion of the four main threats you get from hurricanes, and I'm going to start us off talking about some noted storms for flooding rains as a main impact from the system. Then we're going to get into some forecasting techniques that we use and some forecast products that are out there that you can look at to help get an idea how much rain is going to fall. So, and then we'll finish up with some tools that are out there that will help you assess flooding that may be coming up soon or ongoing. So first of all, I want to ask you a question. Have you experienced a past tropical system that impacted your region with a significant inland flooding threat from heavy rain? So it's a pretty simple poll question to start off, yes or no. And you can go ahead and as you make that selection, for those of you that would like to share the name of the storm or storms that you experienced, you can pop those in the questions box. So I ask some of you go ahead and do that.
All right, those are the results.
All right, and as expected, a vast majority of you have experienced a tropical storm or hurricane that had a significant flooding rain associated with it. And I'm seeing a bunch of Irene's, Faye's, Irma, Rita, a no-name storm, tropical storm Debbie rather. Yeah, that was a prolific rain producer here in the Florida Big Bend, and many others. Well, we're gonna talk about 3 of those storms today. You feel free to continue to Hermine, Gabrielle. So there's been a few. So let's move on. I'm going to discuss Tropical Storm Faye first today. And this goes way back to 2008. And you can see it was impacting the state of Florida for 6 whole days. So that gives you an idea of just what a slow moving system it was. It began affecting the Keys late on the 18th and then zigzagged across the state. We're actually reaching its strongest intensity inland near Lake Okeechobee. The Faye was very slow moving storm that produced extreme rainfall across much of the state and also parts of South Georgia, and an attendant widespread flash flooding and riverine flooding. All right, so let me advance the slide there, sorry about that. So Faye actually made 4 landfalls in the state of Florida, initially in the Keys and then into Southwest Florida. It then briefly emerged off the Florida coast just south of Cape Canaveral and then made a 3rd landfall into Northeast Florida, moving very slowly during this period, and then crossed the state again entering the Appalachia Bay, making its final landfall in Franklin County in the western Florida Big Bend. So rainfall totals exceeded 10 inches, that's in the purple, across much of east central and northeast Florida, as well as the Florida Big Bend and southwest Georgia. Maximum rainfall totals were in excess of 25 inches, occurred locally in parts of east central Florida and southwest Georgia. So Melbourne, Florida takes the prize here with 27.65 inches of rain. Thomasville, Georgia, close second with 27.5, and I believe that was a new Georgia state record. So just some tremendous amounts of rainfall with Faye. Here's pictures associated with Tropical Storm Faye. The one on the left is Lake Ella here in central Tallahassee, not far from where I live. Nearly reached Monroe Street, which is US 27, major north-south thoroughfare in Tallahassee. I don't believe the lake has ever gotten up to it. But anyway, very, very high amount of flooding across poor drainage areas and areas like this. Wakulla County, this is a road that was washed out in the county just south of Leon County, where I'm talking to you from. And then we had major flooding on the Occoquan River that runs down from Georgia and forms the western boundary of Leon and Wakulla counties, and particularly near Havana and Bloxham, or really the entire stretch of the river. Flooding in Bloxham is pictured here. And there was also flooding on the Swanee River. So this was a system that never reached hurricane strength and yet caused, really some devastating flooding because of its slow movement and zigzaggy track. Here's a few more pictures from Faye over from east central Florida in Melbourne, pictured to the left, and quite a bit of flooding on the upper and middle St. Johns River. Some of this may have had to do with surge, but a lot of this I think was freshwater flooding too. So those are the central and right pictures there. All right, jumping ahead 9 years to Hurricane Irma, and we saw several people replying, mentioning Irma Irma was a long track Cape Verde system that spent most of its life as a major hurricane and did indeed make 2 landfalls in Florida as a major hurricane. One in the Keys and another far southwest Florida before it moved up the peninsula roughly along I-75. And while wind and surge and tornadoes were prolific, substantial impacts from the system, flooding was also a problem. So there's the track again, and you can see everywhere east of the track, many areas got in excess of 10 inches of rain, and a few spots in excess of 15. With Fort Pierce, they're having the greatest total rainfall from Irma at 21.66 inches, and that's in spite of the fact that Irma was moving along at a steady pace. I mean, it was especially compared to Faye, the hurricane was moving along steadily and still produced this much rainfall. So you can only imagine what might have happened if it had been a slower moving system. So here's some flooding of a parking lot area there in Callaway on the left. Jacksonville really got hammered by Irma. There was a combination of flooding from heavy rains and also surge flooding from the St. Johns River. I think the flooding in the city was some of the worst they'd seen in 100 years, so really significant impacts there. And we also saw record river and stream flood stages set, including on the Santa Fe River, which nearly forced the closure of I-75. I mean, I think it was like an inch or two at best away from having to close that interstate. And a major US Route 27 was closed due to flooding, and that's a major road that extends from northwest to southeast across the state. So that road did have to get closed down. Okay, and now we have a third storm, and for that, I'm going to pass off the narration to the Warning Coordination in Mobile and Jason Beeman.
Hey, good afternoon, everybody. A storm in our recent memory here from last year, Hurricane Sally, a tremendous impact on the Northwest Florida Panhandle, making landfall, a rapidly intensifying hurricane at landfall, making landfall a strong Category 2 hurricane in Gulf Shores, Alabama on the morning of Wednesday. Let's see here. Mark, you still driving the slideshow?
Oh, is that how it's working? Sorry about that, Jason. I thought you had your own slides. I will bring it back to Mark.
Yeah, I'll be driving until we switch off to.
Okay.
But essentially, making landfall on Gulf Shores, Alabama, almost on the same day, September 16th, as Ivan did 16 years earlier, and putting all the western Florida Panhandle right in that eastern side of the storm. Tremendous amounts of heavy rain that produced prolonged flooding. Sally stalled offshore and was producing heavy rainfall for well over 24 hours and moving at 2 miles per hour or so at times. So just crawling towards the coast. So it was an excruciating time, producing 15 to 30 inches of rain across Northwest Florida, really especially focused along the coast, especially from I-10 south. We had lots of areas that saw 20 to 25 inches of rain in Florida, from Pensacola, especially over to coastal Santa Rosa County. We saw Orange Beach, Alabama, just west of the state line, had rainfall total of 29.99 inches. And so obviously excessive rainfall. We'll go ahead and go to the next slide to kind of look at the rainfall map here and just see kind of the widespread nature of the 15 plus inches of rain that we saw. Mark, if you just go to the next slide when you can. And then we can see, especially there in the dark purple, 15 plus inches across the panhandle, and then that bright purple, greater than 20 inches of rain fell. And again, a lot of areas, especially the Pensacola metro, numerous rain gauge totals of 20 to 25 inches, and some areas were near 30 inches of rain. So this along the coast, so you have all the water, the fresh water that's wanting to drain out into the area bays and waterways, and you had incoming surge as well that was not allowing the water to drain out. So you really had a situation where flooding was made even worse. The total inundation from the surge and the flooding rain along the coast certainly resulted in a very significant situation. If we go to the next slide, you can see some of the impacts that we had. We realized major flooding to near record flooding on several area rivers. I know along the Shoal River in Okaloosa County, we had major flooding. I-10 almost got impacted by that. I think maybe for a brief time they even closed down a stretch of that due to the potential of flooding, or they were very close in watching it. But also in the Blackwater, Wrights Creek, Holmes Creek, Bruce Creek, again, major to near record levels of flooding. Downtown Pensacola was an interesting case because they were getting a top 3 storm surge in recorded history from Sally at the Port of Pensacola. So all this water coming in from Pensacola Bay, you had, again, 20 to 25 inches of rain that was also falling, that was trying to drain out into the bay. That really caused a bad situation in the Pensacola metro. Thousands of water rescues had to take place in and around the metro area during the height of the storm. You can see just a few pictures here, flooding in a Pensacola neighborhood that I think was a combination of surge and the flooding rain like I was just talking about. And again, these stories were repeated all across the Western Florida Panhandle throughout the duration of the storm. We go to the next slide, and you'll see that there was a rare high risk of excessive rain that was in effect for Hurricane Sally. You're going to see more information about this product a little bit later on, but this was notable that this was a high-risk event. These forecasts are not issued lightly, and they're not issued very often, and they indicate when we expect severe, widespread flash flooding and experience it in areas that we don't normally see that flooding. So later on in the presentation, when you see more of that talk about these excessive rainfall outlooks, think back to the storms we just talked about, Sally, Irma, and Faye, and all the other ones that you all listed as well. Certainly, these are the types of events that really we have to watch regardless of the category of storm. So we go to the next slide. That will kind of give us a poll that will be a great lead into our future talk here. What do you think is an important method to educate the public about the threat from these very floods we just talked about? Select one: broadcast media, social media, preparedness websites, the Turn Around Don't Drown campaign, and spotter training. So choose the one that you think is a very important method to help educate the public.
We still have responses coming in, so I'll give it a few more seconds.
Okay. All right, very interesting. Social media, seen the topic there. There's no bad option, that's for sure. It really probably takes a combined approach, but certainly social media, a great new platform for us, but followed right behind by broadcast media. So that kind of leads us right into the next section, part of the talk, where we'll talk about first off, the rainfall forecast, and then we'll get more into the tools to be used during these events.
Thanks, Jason. And I'm Robert Garcia. I'm a senior meteorologist with National Weather Service Forecast Office in Miami. I'm joined by Jen Hubbard, the Tampa Bay Weather Forecast Office in Ruskin. And we're going to talk a little bit about rainfall forecasting and kind of jumping into the process of how the sausage is made, right? One of the things we look at is, well, what are the existing conditions? Are we in drought? Has an area received a lot of recent rainfall? And we have a few different tools that we can use to look at that. Two of them are on the screen right now. The Keach-Byram Drought Index is really popular among some users, especially some of our media partners, and it allows kind of a quick overview of what's going on. You also have the Florida Drought Monitor, which is available. The Weather Service also has on weather.gov the ability to use rainfall data to see how far off in a certain time period an area may be behind or ahead on their normal rainfall amounts, what would be normal over a 30-year average. So there's a bunch of different tools that we can use to assess what has gone on in order to prepare us to forecast what's going on forward. So Mark, if you could hit the slides here when you get a chance, and we're going to move a little bit further. So on the right there, you kind of see an example of what I was speaking of with the rainfall departure from normal product that we have on weather.gov. And it's really easy to access off each office's website. But what's nice is it really gives us a good idea of how much or how little rainfall has fallen over an area over a certain period, whether it be a week, a month, or a season. With all of these things in mind, we can take into consideration just what kind of environment a potential impact from flooding rain could have if we do have, let's say, a tropical system, whether it be a tropical storm, a tropical depression, a hurricane, come through the area. And it also lets us see if there's conditions that have been exacerbated. Maybe we've had recent rainfall. Maybe certain parts of the season we may have a cold front nearby that has created rainfall that has been heavy at times. At the same time, we can also look at area of rivers and lakes and creeks and streams to kind of get an idea of what water managers are concerned with and what kind of conditions they've been working with for the last few days or going back even through a wet season. Moving to the next slide, we kind of look at coordination. And so one of the big things is, depending on where you are in the state, there are different ways to think about as you go further north in the state, you enter more riverine systems. There are still maybe some controlled areas, maybe a dam or some other structure. But as you come further south across the peninsula, the further south you go, the more engineered the hydrological interface is. And so no matter where you are, it's kind of like a highway system. We think about our interstates, then our main arterials, and then finally entering neighborhood streets. And with water, it's kind of the opposite. As what many folks think, okay, I use the interstate to get to somebody's house. Well, when you leave your house, you have to leave your neighborhood on a local street, reach an arterial, and from there you can access the interstate. Well, it's very similar with water. And as Jason was speaking to earlier with Sally, sometimes if you have other water in those areas that can make it difficult for your newly acquired water to drain, it can create a flooding situation that can be exacerbated. And so here, this is an example from the South Florida Water Management District of kind of a schematic of how some of the systems are in South and Central Florida. And you can see here, some of you may wear hats as floodplain managers, or you help with water management. And this is kind of like a good overview of how that relationship between water management districts, the Army Corps of Engineers, local and tribal governments, special districts, and then private landowners and associations that all come together to manage our water. So it's part of the coordination at times that some of the offices may do with water management districts that do forecast rainfall. Some of them do, some of them don't. But those that do can reach out to local forecast offices and the other parts of the Weather Service to try to coordinate this. So moving to our next slide, we kind of explore a little bit more about water management and the relationship and the coordination and how intertwined we are. On the left, you see a map. You see every portion of the state is covered by a water management district. There's 5. A lot of folks may not realize that the Everglades, the headwaters begin near the Walt Disney World Resort, come on down to Lake Okeechobee, and from there get distributed amongst the different portions. Southwest Florida and the St. Johns Rivers also have some of their headwaters in those areas. And then you have the Suwannee River in Northwest Florida water management districts, which handle the more traditional riverine areas in the northern part of the state. So it's a combined effort. On the right, I try to produce a graphic that kind of shows most of the formal to informal relationships. But as you can see, there's quite a bit of intertwining, and it requires coordination. And if you maybe have that water management or floodplain manager cap on, or maybe you're helping decision-making, informed decision-making, regards to maybe how to deploy pumps or prepare or mitigate for water issues, feel free to reach out to your local forecast office, or maybe some things we can help you with, especially when it comes to the forecast and interpreting it. So as we move into the next portion of the forecasting process, probabilistic forecasts are something that can be kind of scary. Most folks just want to know, how much rain am I going to get? But the thing is, if we only share with you the most likely scenario, right, the forecast, it may not help you account for a range of possibilities and impacts that could allow you to make better decisions to prepare your community. And so, Mark, if you mind clicking one time, we're going to talk a little bit. This may be an example graphic here of what you may see with a forecast. It's the expected rainfall. You notice there's a range given, but at the same time, this is still in the middle part of the range. It doesn't necessarily give you what you may want to prepare for, a plausible worst case scenario. You may have heard that in some of the earlier talks this week. Well, rainfall, I can tie in as well. You may not have the worst possible case scenario, but let's say what would be 9 out of 10 worst case, right? And so on the next graphic that'll pop up hopefully here, Mark, if you're able, there we go. You can actually see for this event that I pulled up back in August of 2019, we have the 1 in 10, and you can see some portions of the eastern southeastern Florida metropolitan areas. We're talking in the range of 5 to 6 inches, which is something that could create concerns, especially in some of the areas that are trying to work on some of their drainage projects, or that had seen additional rainfall in earlier days. So rainfall forecasts are also quickly becoming probabilistic, and this is a really exciting development that hopefully will help everyone make better preparedness calls, just because you'll have more information than just what the expected amount is, but you can also see maybe some of these more extreme events a little bit more with a crystal ball. So I think the next slide, Ms. Jen, if you want to come on in.
Okay, there we go. Hi, everybody. Jen Hubbard here. And so now we're going to start to talk about the excessive rainfall outlook. So what this is a product that is kind of similar to what you would think of with the severe weather outlook, where it is like a risk graphic that is going to give you marginal risk, slight risk, moderate risk, or high risk of rainfall exceeding flash flood guidance. So it is maybe a small percentage risk, but of an extreme event. You know, you say a 10% risk of rainfall, well, that's not a very big thing. I'll go ahead and risk that. But a 10% risk that your house is going to get flooded, that's a big deal. So think of it kind of on those same terms. And you can get either the national product, which is on the right, or we can tailor it more down to the state or local level, which is what we see in the middle there. And it is a 24-hour product that is in effect for days 1 through 3. And so we can kind of see the evolution of where we expect those risk areas to be from day 1 through day 3 as the storm moves through the area. These are examples from Tropical Storm Eta. And next slide, please. And one thing that's new this year is that they are going to be creating a multi-day graphic that's going to, next slide, Mark. It's going to combine all 3 days into one quick look product, but it is going to still have the days 1 through 3 separated on the side, so you can still see that evolution, but it's going to have them all combined into one product, so you can see in a quick look where your greatest threat is going to be for the entire tropical event. So we also have listed here what those risk categories are specifically. And so for a marginal risk, that typically equates to isolated flash flooding possible. A slight risk is scattered flash floods possible. Moderate risk means that numerous flash floods are likely, and a high risk is widespread flash flooding is expected. Next slide. Now keep that in mind as we transition now to looking at the flooding, rain, hurricane threat, and impact graphic. Now what this is a graphic that is made at the local WFO level, and it is going to fairly mirror the excessive rainfall multi-day graphic. However, there are a few differences. This will be available starting once an area is under the 5-day cone of uncertainty consistently for 24 hours. So it's available for a little bit longer time frame sometimes than what the excessive rainfall outlook may be viewing. And it is looking for the entire event of when that tropical system is expected to be impacting an area. So not just 3 days. And in addition to that, it's not only taking the excessive rainfall outlook, but it's also looking at just how much rain is expected to fall in that reasonable worst case scenario. And if it exceeds a certain threshold, it's going to increase that category by 1. But otherwise, the coloring is slightly different than what you see in the excessive rainfall outlook, but the threat levels are essentially the same, with localized, then moderate, major, and extreme flooding for the different color categories. Excuse me. Next slide, please. So the HTI can be found at the website that'll be listed here. And once we get under watches and warnings, you can click at a specific point on those maps from this website and get like the point and click forecast that we have on our regular web page. You can get hurricane point and click information from these threat graphics. So the what, where, when, how much, how long, and what to prepare for pulled directly from our TCV product for that specific point. So there's a lot of information that you can gain just from these graphics. Next slide, please. Now we're going to look at our flood watches and warnings that we have. Our flood watches can begin well ahead of when other tropical watches and warnings go up, and they can also remain well after the other tropical watches and warnings have subsided. We begin our watches typically once we start to see lots of impacts from rainfall already occurring, which we can get in bands that reach far out from where the main storm system is. We can also have systems that either are very slow moving and start to weaken or stall out, kind of like Harvey, where the rainfall is kind of all that lingers for days afterwards. But these watches typically are for a widespread area and will stay in effect through the majority of the storm. And then you'll start to see smaller localized warning areas where we are seeing the flooding taking place. These will finally be removed once we have the rainfall threat over with, but then you will typically see transitions into river flood warnings as all that water then starts to drain into our river basins. Next slide, please. You can track how much rain is falling throughout the event by going to our AHIPS page on our website, and I'll give that link in just a minute. But the precipitation tab on that page is shown on the right-hand graphic there. And you can query whatever time frame you'd like to see for how much rain has fallen, and that's taken directly from our radar. So it's a radar estimated rainfall amounts. And we will typically put this up in our briefings that we give to our emergency managers and highlight just how much rain has already fallen so that we can take a look at what's happening, see how it's comparing to what we were expecting in our forecasts, and make any adjustments that need to be made to both the amount forecast and those outlook products. Next slide, please. This is a look at what the river forecasts then look like on that AHIPS page, and there's the link for it. It provides the observed water levels in the blue there, and then we get to the current time frame with that line, that vertical line, and then as it transitions into the purple, that's the forecast for how the river is expected to be over the next several days. And it gives you also that peak river, the peak height that it's expected to reach. And the color coding at the top corresponds with action, minor, moderate, and major flood stage levels for each point. Now, something to remember with river flooding is that during a tropical event, especially in the peninsula part of Florida, we have really flat terrain, and so sometimes it can take weeks for the rivers to fall below flood stage with these tropical rainfall events. Next slide, please. And this is what you get the main page when you go to that website. It's a quick look overview of all of the stage points that we have across the state. And these are also color coded with the same coloring as what we had in the previous slide of the different minor, moderate, and major flood stages. If you hover over a point, then it will give you those graphs that we had in the previous slide in pop-up form. So you can quickly transition between different sites within your area, or you can click on it and it will go to a new page that has some additional information of what impacts are at different flood points. Now, this page also has some coastal information that you can get tidal gauges and surge information for. So it's got a lot of information just on this one site. And with that, I believe we are transitioning to Kelly Godsey. Thank you.
All right. Hi, good afternoon, everyone. This is Kelly with the Weather Service in Tallahassee. I'm the Senior Service Hydrologist and Meteorologist here at the Weather Service in Tallahassee. Where I'm going to pick up today is I'm going to talk a little bit about some of the available tools that we have for our riverine flooding across the state, and spend some time talking about the different resources that are available. Flood mapping varies quite a bit based on how it is produced and when it is made. And so we want to make sure that everyone is aware of the different resources that are available. It's going to vary a little bit by region across Florida. There are some new types of flood mapping that's going to be available as we go into this hurricane season, and many to come with the National Water Center that is coming online. So first, I wanted to talk about the flood inundation maps that exist on the AHIPS page. These are maps that are made specifically for select sites. There are a number across the state of Florida. As you can see in the inset map here, they range from a site on the Apalachicola River, several that are on the Suwannee, and then even more as we go down into West Central Florida. What's important to understand about these maps is that they depict water depth in addition to flood extent along the mapped reach of the river. Now, these are static maps, they're not dynamic. So when we look at a specific stage, that's showing the area that's expected to flood at that specific level. When we go a little bit further into our view of this map, we're actually able to determine water depth. And I'm going to pop out of the presentation just briefly and kind of demonstrate how you could access this information. And I'm going to use as an example the Suwannee River at Dowling Park. You'll notice on the main AHIPS page, there is a link here at the top that says inundation mapping. If you click on inundation mapping, it'll pop up a new link that'll show you the interface to view flood mapping for this site. This is a zoomable mapping interface. You can go in or out based on the view that you would like. On the left-hand side, you'll notice there's a number of stages that exist. Now, whichever stage level you pick, it will redraw the flood map to show the areas that are impacted at that specific stage. In this example, if we zoom in to the area on the east side of the river and it redraws, you can actually click on the interface and it will show you what the water depth is approximated at that particular location. So if you're concerned about a specific address, you can actually go through and get that information. We can remove that marker, go to a different location and look around based on our needs for a specific site. Again, these are location specific and they're static. They tend to only cover about 2 to 3 miles upstream of the gauge and about 2 to 3 miles downstream, depending on how they're constructed. Some other tools that we have available are flood extent maps, and these are fairly new. We have a number of these across North Florida, even down into portions of Central Florida. These are a little different than flood inundation maps in that they are simply kind of doing what the term implies, showing the extent of the flooding, but we're not getting into the water depth. This model that we use to generate these maps cannot show how deep the water is along the area that is mapped, instead showing areas that are expected to be wet at a specific stage. Now, in the screenshot that you see here, this is for the Santa Fe River near Alena State Park, and you may recognize I-75 running down this portion of the screen. This was the location where we very nearly, during Hurricane Irma, ended up flooding I-75. We were within about 8 inches of the base of the bridge, this one here, over the Santa Fe River. What this mapping here will allow us to do is we can zoom in and out and look at various stages. Much like the flood inundation maps, it goes a couple of feet above the record stages. And so if you'll just bear with me for a moment, I'd like to demonstrate how this particular mapping interface works. And so when you load the flood map for this particular page, you can actually zoom in. It will refresh the image. And you'll notice in particular, it's showing that there are flooded areas here on either side of the interstate. When we change to a different level, it will resume and show us where we have flooding in the shaded area. In this case, it shows an impact to the I-75 bridge, very near 57 feet, with a comment over here to the left. Another thing that I do want to reference is that you can go to a slightly higher stage and see what a record flood might look like for this location. And again, it's zoomable, looking at whichever reach that you would like to see. So back into the presentation here, there's an example that I'd like to use. Jason spoke about Hurricane Sally that we had last year. And right before Hurricane Sally, we fielded this flood extent map for the Shoal River near Mossy Head in Walton County. And what was interesting about this particular case was that we had no way of knowing going into the event that we were going to have this much rain in Walton County. But we had over 15 inches of rain in the headwater portion of the Shoal River. And you can see the hydrograph there as we were nearing the crest. We ended up going just above 25.5 feet. And this is a view of what the flood extent map showed for this portion of Walton County. Now, working with our partners before the event, we were able to determine at what level bridges are impacted and include that in this mapping interface. It was extremely important, not only for our local partners, but state partners to be able to see this information. And so again, as the forecast changed, the ability to see higher levels in the anticipated impacts was very important. Obviously, the goals for mapping technologies like this, or any flood inundation maps, is that we get a visualization of what that flood looks like. Of course, with any of our AHIPS points, we include impact statements that describe what will flood at a specific stage. But a picture is much more powerful to really show those impacts as you go up and downstream throughout a river. Additionally, we work closely with our local and state partners to validate the information that comes out of the model. In any of the flood mapping that you've seen, we actually get bridge surveys and other information from county or state DOT to make sure that we are showing impacts to roads and associated bridges at the appropriate levels. Now, again, I do want to emphasize that the maps that have been shown thus far are static. That means that it's not something where, you know, when the river gauge says 15 feet, that's what's occurring at that point at the gauge, and then we're just waiting on an update to the map to see the flood wave move downstream. They're static. And so when we say, for example, in this case, this is showing 18 feet, those are the areas that are likely to get wet when the river reaches 18 feet. Now, there's travel time involved from where the reference gauge is located to where maybe downstream flooding is going to occur. And in this particular example, it takes 18 hours for the water to go from this location to this location. And so it's important for us to message that appropriately when we're working with our partners, but also sharing this with other emergency managers at the state level and above. And so again, remember, these are static maps, not dynamic. They don't show the flood wave as it progresses through the basin. Another thing that I want to mention is that the National Water Center in Tuscaloosa, Alabama, has a water predictions operations division, and they are creating a variety of flood maps that are covering locations where there are not necessarily river gauges. They can cover the headwater stream reaches where there are no gauges. They can even go in and start to provide flood mapping for locations along our main stem rivers. And here's an example from a flood case in the state of Tennessee, where they're depicting flood inundation along a specific river. Now, they use two different types of techniques for this. They do have the national water model that is using rainfall forecasts from the GFS model to produce flooding across the entire country. And we can go in and look at these flood maps and see how they are performing in a specific case. There's a more common technique that they use now that's referred to as replace and route, where we rely on our River Forecast Center partners and the predictions that they make for various river gauges. And the Water Center simulates those forecasts from point to point, generating a flood inundation map. And so those are new capabilities that we're starting late last season and are now going to be much more common as we go into this hurricane season. If you want to learn more about the National Water output, the National Water Model output, or ways to access the data, you'll want to make sure you're working through your local Weather Service office, and they're your interface to the National Water Center. And there's ways that we can actually get you these maps when we get into significant flood events, like we've seen in past tropical cases. So there's a variety of sources out there for flood mapping. It's important that everyone kind of understand how each of these flood maps works and how they're built, and that's where a lot of times floodplain managers and water partners will really have a good feel for that. And again, when we look at these maps, what we're talking about is getting a picture of what that flood will look like. And as we go through any event, that can be extremely powerful as we share that with the public to compel action, trying to get people out of the way. So that's the material that I wanted to show. I believe one last thing that I did want to mention is talking about recurrence intervals. We end up hearing people say a lot that, when we've had a 100-year flood, is it going to be another 100 years before we get another one? And what we would really encourage folks to do is refer to some of these significant events by their exceedance probabilities. These exceedance probabilities help us communicate the chance of a specific event occurring over a given period of time. And so when we talk about a 100-year flood, we're really talking about an event that has a 1% annual chance of occurrence. So it's entirely possible to say have 2 5-year events within the same year. If you get a Sally and then you get another storm that comes right behind it, certainly those are significant events. We don't want folks to think, well, I've had that 20-year, 50-year event. I can't have another one for another 20 or 50 years. We want to think in terms of these exceedance probabilities. Now, if you look for the NOAA Atlas 14 on Google, or some of the new normals that are going to be coming out soon, you can actually get frequency tables for what your recurrence interval is, and then you just take the inverse of that, and that gives you the exceedance probability, like we've shown here in this table. So a 500-year event has an annual exceedance probability of 0.2%. And so again, how we quantify those types of events and communicate that to the public, we'd certainly prefer to see the exceedance probability be used as opposed to the recurrence interval that references a 50 or 100-year flood. So now I actually do believe that we've got a couple of poll questions coming up for the group. So this first poll question is, can you get 2 100-year floods in the same year? I'll hand it back to Dan for saying I'm not seeing the poll pop up, but Dan, you want to jump in?
Sure, yes, it's 96%.
All right, great. Yeah, and when we think about the annual exceedance probabilities, a 1% annual chance, each for a 100-year type flood, and it's certainly possible. when you think about some of the tropical events across the Gulf, Houston in particular, they've seen multiple 100-year floods in the same season. So certainly something that we can see happen in Florida, no doubt. Our next poll question for this one is, which tool or product that we've shown today in the presentations for flooding looks most useful to you?
All right, about 20% of the people have voted so far, and we're going up quickly. Getting up to 50% of people have voted. All right, we're starting to slow down, so I'm going to go ahead and close the poll and share the results. And the multi-day excessive rainfall outlook wins with 35%, then inundation maps 30%, and flood extent 24%.
All right, great. All right, yeah, thank you everyone for participating in the polls and what we see here. And again, I would encourage everyone, particularly on the flood mapping that exists, to make sure that you reach out to your local weather office and learn about the capabilities and mapping sources that they have available to provide to you during these heavy rainfall events. That's all the material that I have at this point. I believe, are we handing it over to the Division of Emergency Management at this point, Dan?
Yes, so thank you, Kelly. And we're excited to have Amy Godsey with us, the Chief State Meteorologist from the Division of Emergency Management. And so Amy, we'll pass it to you.
All right, hey, thanks for letting me join your discussion today. Again, you've seen that there are many variables that go into flood forecasting and flood impacts across the entire state of Florida. And so again, that goes to again, an end road of communication challenges. It is very difficult for people to visualize flooding impacts across the state, and really hammering the message that flooding impacts, especially from tropical systems, are irrespective of category. So many times we've seen our citizens focus on the category of storm, but we've seen over and over again in Florida and other areas of the country that lower end hurricanes and tropical storms can have significant flood impacts where people take years or possibly even decades to recover from. So again, communicating that risk, that it's irrespective of the hurricane category, is one of the messages that we're going to push this year if we do see a flood impact. We've done it in previous storms, but I think we can continue to make more progress on that. And getting people to understand, what does 6 to 12 inches of rain look like? It's hard for people to visualize that. They just think about maybe a ruler, but the runoff impact and how 12 inches can easily in certain areas turn into 3 feet of water depth. Getting people to understand that possibility is something we're continuing to work on from a messaging standpoint up here. Certainly the advancements in technology, you've seen the flooding mapping possibilities and solutions from the National Weather Service and others that's helping, again, people understand that visualization of flood risk. Augmented reality is becoming a bigger topic and being developed amongst other companies. Again, getting people to understand and actually visualize it. Sometimes it just takes people to see the flooding before they can understand what it could do to their home and their businesses. And of course, historical pictures are helpful. But again, until they actually experience a flood impact, it's hard for them to understand what they need to do to prepare. That is why we've added the Know Your Home to the Know Your Zone campaign. We've really pushed the message of knowing evacuation zones and their risk to storm surge flooding, but adding that extra layer of freshwater flooding and knowing their home's vulnerability is why we've added that slogan to that campaign. Taking an aerial risk, an aerial survey of your home, looking at the trees. I do, and I know I'm a meteorologist, but it's, getting people to take that survey and that assessment of their property to see what their vulnerabilities are. Are they susceptible to tree damage? Are they susceptible to flooding? And now it sounds like a cheesy term, but if it can flood, if it can rain at your house, it can flood. But that's really, true in the state of Florida, given our terrain and the amount of flooding and water that we can see from these systems in this part of the region. So again, also thinking beyond your home, Robert kind of mentioned this about looking at a larger look at your neighborhood. You know, do you have to go up a hill to get to your home? I do. So looking at, canal systems. I grew up in a house where a canal was just a block away, and that could obviously in a significant event impact, you may not have major damage to your home, but you could certainly be isolated. And we've seen many cases of that across the state in recent events where homes become isolated, they require evacuation post-storm and sheltering needs on the human services side. So again, I think we can just continue to push that message and getting people to prepare themselves and their families and businesses for flooding impacts is certainly something we're focused on. And I know Director Guthrie is very passionate about flood protection and mitigation through the National Flood Insurance Program. So we're going to continue to push that message as well. So thanks for letting me join and add a few comments.
Thank you, Amy. I really liked that campaign that you mentioned too. So can you remind us what that is again?
Yeah, sure. The Know Your Zone, Know Your Home campaign, again, started many years ago, just, getting people to understand their storm surge risk and understand what evacuation zone they are in for storm surge flooding. But a few years ago, we added Know Your Home. And we've seen many times, we've seen it in Hurricane Michael and other hurricanes where we've had, unfortunately, people lose their lives due to trees being downed, due to flooding impacts, people being stranded, cut off. Unfortunately, they may drown if they live near a riverine system. So we've added that extra layer. Most Floridians don't live in a storm surge evacuation zone. That is a coastal impact. And so, but hurricanes we've seen impact entire states, entire counties, neighborhoods, jurisdictions, and multiple areas of the state. So getting people to understand that hurricanes are not just a coastal event, they can have significant impacts inland, especially when it comes to freshwater flooding, is why we really wanted to add that extra layer of preparedness to get people to look at the entire scope of impact of a hurricane. It's not just the wind, it's not just the storm surge. There's tornado impacts and certainly freshwater flooding impacts that people need to pay attention to.